Hello everyone, I am Vaishnavi Srivas and in this video we are going to cover the second topic of the data science course, that is data preparation. So let's start. Data preparation is a crucial step in data science as it ensures that data is clean, consistent and ready for analysis. It involves a series of steps that transform raw data into a format that can be used for building predictive model. So basically what data preparation means that the data we get, it's not necessary that is clean and it is easy to analyze. So first, the data we get for analysis, we first clean it and make it consistent that either contains missing values or repetitive values, similar values. So we remove that so that it becomes easy to analyze. So when data is consistent and clean, it becomes easy for us to process it and analyze it and predict what we can do, what that data wants to show us to our the message that data wants to convey. So why data preparation is crucial? First, accuracy. Accuracy models require clean data. Inaccurate data leads to skewed results and unreliable insights. So, accuracy, yes, it is very important in the data that the data we are doing analysis of should be accurate. It should not be inaccurate or contain irrelevant information that is not useful. Inaccurate data or inconsistent data may create problem for analysis and it will not give the proper result as we want. Second is consistency. Consistent data ensures that all values are in the same format, making it easier to analyze and compare. Consistent, that the data which we are using should be consistent. It should like for example gender, sometime it should not do like that. For male it is writing m and sometime it is writing the whole word male, and similarly for the female sometime it writes f or sometime it writes the word female. It should be consistent, like it should write same thing. If it is using the first letter or it is using the word, then it should be consistent throughout the data. If it uses both, then it will be misleading and it create problem for the user. Third is efficiency. Well prepared data reduces the time and effort required for analysis, allowing for faster model development. Obviously, the data should be efficient, which we want to analysis. Now, data collection and exploration. Data sources. Identify the sources of the data, including databases, APIs, or web scraping. Data extraction. Extract data from its source using appropriate tools and techniques. Data cleaning. Remove duplicates, handle missing values, and correct inconsistencies in the data. Handling missing values. Now, how you can handle the missing values? Deletion. Remove rows or column with missing values. This can be effective when the missing data is minimal. Second is imputation. Replacing missing values with estimated values based on other data points. This helps preserve data integrity. Now, handling missing values. So, by two ways you can handle the missing values, that is deletion and imputation. You can simply delete the rows or column where the data is missing, but it may create problem that if so many data are missing, then it will then we will remove so many rows, so this may create problem for analysis. Second is imputation. Replace missing value with estimated value, as we can estimate values from the previous values or the values we already have in our data. So means we can put some values by our choice or estimation by mean mode median to whatever value we want to put. Deleting is also a good option, but it for big data where missing values are missing values are very large, so that there it may create problem. Dealing with outliers. Identify outliers. Use statistical method to identify data points that deviate significantly from the rest of the data. Analyze outliers. Determine the cause of outliers. They could be error or legitimate data point that need to be addressed. Handle outliers. Remove outliers if they are error or adjust them if they represent valid but extreme data points. Feature engineering, feature creation and feature selection. Combine existing feature or create new ones to improve model performance. Feature selection, choose the most relevant feature for the task at hand, eliminating irrelevant ones. So what feature engineering means? Creation and selection. So you can create new features by the existing and improve your performance, and selecting when the most you are selecting most relevant data and using that for the analysis. Data transformation and normalization. Data transformation. Convert data to a different scale or distribution. Improve model performance by addressing skewed data. Normalization. Scale data to a specific range, typically between 0 and 1. Enhance model performance by standardizing data across different features. Evaluation and iteration. Model evaluation. Evaluate the performance of the model using appropriate metrics. Data refinement. Refine the data preparation process based on model evaluation results. Iterative process. Continue to iterate on data preparation and model development until optimal performance is achieved. Thank you. That's all for this video. I hope you liked the video.